Let's start our class for today. Right, so today we're going to look at this, continue our class, which is we are still in how to write a C programming for the GPIO of the STM32. Okay, so today we are going to look at this 7-segment display. Okay, so why we need to look at this 7-segment display? Because there are applications where you need to display a decimal digit, okay, using a 7-segment LED display. Okay, and the display could represent the number of times a switch was pressed, or if you're going to do some counting sequence, okay, you're going to display the counter sequence, okay, the timer. So we are going to use this 7-segment display to display the digit, okay, the decimal digits. All right, and using this 7-segment display, a digit 0 to 9 and a hex A to 7, A to F can be displayed by giving the proper 7-segment codes. Okay, so here, okay, we're going to look at how to find, okay, how to generate a code. Okay, what are the code that is needed in order to display these numbers here? Okay, so if you can see here, the 7-segment display consists of 8 LEDs. Okay, first LED denoted as a A, followed by LED B, C, D, E, F, G, and another LED called a DP. Okay, so we have a total of 8 LEDs lah. Okay, that is used to make up a 1-7-segment display. Okay, and this LED A is actually the least significant bit, while DP is the most significant bit. Okay, so when we're going to find out the proper 7-segment code, okay, we will start it from least significant bit, which is A. Okay, and then B, C, D, E, F, G, H, or sometimes we call it as a DP. DP is a decimal point lah. Okay. Okay, so now we are going to find out, okay, what are the value that we need to give in order to display a certain digit or a certain hex, okay, to display a character or a decimal digit. Let's say now you're going to display 0, okay. So to display 0, we look at the 7-segment display. To display 0, okay, A should be light on, turn on. B also turn on. C, D, E, and F. Okay, and let's assume that the 7-segment display that we're going to use is a common cathode. Okay, so for the common cathode, we know that if you're going to light up the LED, you need to give 1, okay, to turn it on, and give 0 to turn it off. Okay, so here, in order to display 0, so what you need to do here is, okay, LED A should be turned on, B, C, D, E, F also need to be turned on, okay, while DP and G, okay, need to be turned off. Then after that, okay, number 0 will be displayed on the 7-segment. Okay, and what would be the number that you, what would be the proper 7-segment codes here? Okay, so here we convert it to hexadecimal because we're going to send this number to the GPIO port, right? So the number will be, if you change it to what we call here to hexadecimal, it will be, okay, so if 8421, 8421, okay, and then you change it to decimal to display number 0, okay, you need to give 3F to your GPIO port or GPIO ODR. Okay, when you give 3F to GPIO ODR, then after that, your 7 segment will display number 0, digit 0. Okay, let's say lah. Now we are going to display number 6. Okay, to display number 6, okay, we need to identify lah. Okay, which LED need to be turned on and which LED need to be turned off. Okay, so here, okay, to display 6, the LED need to be turned on is A, F, E, D, P, and G. Okay, so what we need to do? Okay, so next, okay, we need to give 1 to LED A, B is 0, C 1, D, E, F, and G also 1, while decimal point, okay, you give 0. And based on this code here, okay, the code that you already determined, okay, to display number 6 on the 7 segment, then you change it to hexadecimal, which is equivalent to 7, 8 plus 4 is 12, plus 1 is 13, 30 is a BCD, okay? When you give a 7D to GPIO ODR, then after that, your 7 segment will display number 6, okay? So the rest you can find it by yourself, okay? So you need to know lah, okay, which 7 segment need to be turned on, which 7 segment need to be turned off. Then after that, okay, find what are the proper 7 segment codes. Once you get it, then after that, that codes you need to give it to your GPIO ODR. Okay, so as I mentioned previously, okay, the 7 segment as well as the LEDs have a 2 common types. Okay, the first one we call it as a common anode, and the second one we call it as a common cathode. Okay, for the common anode, how are you going to know? Okay, this one is a common anode, this one is common cathode. Okay, for the common anode, you can see here, okay, this pin, okay, need to be connected to VCC. Okay, you can have one pin here, okay, which is this pin need to connect it to VCC. And if you look at the data sheet of your 7 segments, okay, you can see that the positive terminal, okay, of your LEDs inside of the 7 segment all are connected to VCC. Okay, so you can see if I highlight here, okay, all the positive terminals connected to VCC. Okay, you can see this one is connected to VCC, VCC, VCC. This one also connected to VCC. Then you know that is a common anode. Okay, so for the common anode, to turn the LED, to turn on the LED, okay, for common anode, turn on LED, you need to give 0 lah. Okay, so 0 will turn on, while you give 1, it will turn off. Compared to, as opposed to a common cathode, 1, the LED will turn on, and if you give 0, the LED will turn off. Okay, so common cathode, you can see here, okay, this pin needs to be connected to ground. Okay, and based on the apa ni kita panggil the connection inside of the 7 segment, okay, you can see here that all the negative terminal are connected to same, okay, ground. Okay, can I have few minutes here? Okay, I need to take a call sekejap ya. Excuse me. Okay, so sorry for the interruption just now. Okay, so now we're going to look at this is another how the 7 segment for the common ended and communicated. Okay, looks like when you look at the circuits here, okay, we can see here for the common ended 7 segment. Okay, so this is the LEDs. Okay, we can see we have 8 LEDs are connected together. And based on this LED, for the common ended, all of the positive terminal, okay, you can see the positive terminal of these LEDs are connected to the same common, which is a VCC. Okay, so now we know that it is a belong to common ended. Why this one, okay, the other end needs to be connected to your STM32 GPIO pin. Okay, for the communicated for same, okay, similar to common ended, which is here you can see here the negative terminal are all are connected to the same common, which is ground. Okay, and then the other end will be need to be connected to STM32 GPIO port. Right. So now, okay, we're going to look at exercise lah. Okay, how to write a program for the 7 segment. Okay, here. Okay, 7 segment is connected to port C. Okay, you are need to write a code that display number 1 on the 7 segment. Okay, and we assume that this is a communicated lah. Kita pakai communicated. Okay, so before we write down the programs, okay, first what you need to do here is we need to find out what would be the codes lah need to be given to the GPIO ODR in order to display 1 to LEDs to the 7 segments. Okay, so here we can see, okay, we have communicated. Communicated, we know give 1, the LED will turn on, give 0, it will turn off, and then we just going to find out what would be the code need to be given to the 7 segment. Okay, A, B, C, D, E, F, C, H. H is a decimal point lah. Another label is a DP. Right. So here, based on this, we need to display number 1. Okay, to display number 1, LED B and C, okay, should be turned on, while the rest of the LED need to be turned off. Okay, and then based on this here, okay, we know that the value will be 0, 6. Okay, this is the value that you need to give to your port C, GPIO C ODR. Okay, now once we already identified the value that we need to give to the 7, then after that we started with the main program. Okay, so first, what you need to do, okay, based on the previous example that we did in the last class, okay, the first thing that you need to do here is you need to include, okay, STM32 file. Okay, so don't forget to include this file here, STM32F4XX.h5. Okay, after you include this file, then after that we started with main program. Okay, so the very first thing that you need to do inside of the main program, what is this? What is that? Okay, can you tell me what is the first thing that you need to do under the main program?
Initializing clock.
Okay, enable the GPIO clock. Okay, based on this here, okay, the GPIO clock that we need to enable is a port C. Okay, so where are we going to enable GPIO clock at? This register, RCCHB1ENR register. And now we are going to identify lah. Okay, what would be the value that we need to give to this register? Okay, what value that you need to give? Okay, for the AHB1 ENR register, okay, we only look at the last 8 bit, okay, from this register. Okay, so we know that this is a port A, B, C, D, E, F, G, and H. Okay, since this is a port C, okay, so what you need to do is you need to give 1 lah to port C, while the rest of the port you give 0. And when you change it to hexadecimal, okay, it will give you 0x04. Okay, so now you already enabled the port C. Okay, the GPIO clock for the port C. Step number 2. Okay, what will be the step number 2? Okay, determine, okay, the port, whether you're going to make it as an output port or input port. Okay, and since now the port C, okay, from PC, okay, we started from PC0 lah. PC0 until PC7, okay, you're going to connect to 7 segment. Okay, and this 7 segment is an output, so you need to make sure that your port C become output port, okay, which is from PC0 to PC7. So here in the model, okay, you need to give GPIOC model equal to what value? 0x. What value that you need to give to the model register? To make it an output port, you need to give 0, 1 for each of the model. Okay, if you give 0, 0, it become input port. 0, 1 is output port. 1, 0 is another function. 1, 1 is for analog. Okay, 1, 0 is an alternate function. 1, 1 is for the analog. Okay, so we need to give 0, 1 to the mode register. Okay, so give 0, 1 to mod 0 until model 7. Okay, we have a total of model 0 until model 15, but we only use model 0 to model 7 because only 8 pins are connected to 7 segments. Okay, and the value will be 5, 5, 5, 5. Okay, and then next, step number 3. What will be the step number 3? Okay, you need to determine lah. Okay, you need to select, okay, your GPIO port, because this is an output port. You're going to make it operate under the push-pull or open drain. Okay, so to be safe, okay, because this is a 7 segment, the 7 segment requires a very stable logic high and logic low. Okay, we're going to use a push-pull. Okay, so the output must be operates under push-pull mode. Okay, where we're going to do it, set that. Okay, to set, we need to set the push-pull mode or the open drain mode. Okay, we need to set it at the O type register. Okay, so just give 0, then after that, okay, you set your GPIOC output to operate in the push-pull mode. Okay. Anything we need to initialize from based on the previous classes? Ada lagi tak? Anything? Kitchen? Anything we need to initialize? Okay, we already initialized these 3 registers.
So can start the program, I think.
Okay, we can start with the program. Okay, we can start sending number 1 to the 7 segment. Okay, so use a while loop. Okay, while 1, and then next is a GPIOC. Okay, ODR. Okay, because this is the output. When you're going to send the data to the output, we use the ODR equal to what value? Okay, this is the value lah. Okay, we already identified the value, which is a 06, in order to display number 1. Okay, so GPIO ODR followed by 0x0 6. Then after that, number 1 will be displayed to port C. Okay, to the 7 segments that are connected to port C. Okay, so this is the program. Okay, so next, moving on to another 7 segment. Okay, this 7 segment here connected to another decoder called as a external decoder for 7 segment display. Okay, so this decoder is an integrated circuit that simplifies, okay, it simplifies the process of controlling the 7 segment display. Okay, the decoder takes the binary or a BCD, okay, binary code decimal. Okay, we already learned about it, the binary code decimal input, and translate it into the correct combination of the segment activation to display the desired digit of character. Okay, so here you can see here, this is the 7 segment. Okay, previously what happened here is, from this 7 segment, we have a total of 8 LEDs. All 8 LEDs are connected to your GPIO pins. But now, what happened here is, by using the decoder, okay, the LEDs here, the LED pins, which is A, B, C, D, E, F, G until C, need to be connected to this decoder. Okay, and then from this decoder, okay, only 4 pins are needed. Okay, which is, we call it as a BCD input. Why we need to have this BCD decoder here? Because it will translate, okay, the input that you put under this BCD input, it will translate and get in the proper 7 segment code. Means that you no longer require to find out all of these codes here, okay, in order to display a certain digit. Okay, for example, if you're going to display 0, okay, you just give 0, 0, 0, 0 to this BCD input. Okay, this is a BCD input. Okay, we have 4 inputs. Okay, so you need to give 0, 0, 0. Then after that, it will display 0. Okay, if you're going to display 1 to your 7 segment, okay, just give 0, 0, 0, 1. Okay, so we know that this is a binary code decimal. Okay, binary code decimal, we know that it uses the 8421 method. Okay, you already learned about it in the module 0. Okay, 8421 method, which is, if you're going to display, to convert from binary to decimal, okay, for example, number 2, okay, the binary code decimal code value is a 0, 0, 1, 0. Okay, if number 3, 0, 0, 1, 1. Okay, if you're going to display number 9, to display number 9, the code will be 1, 0, 0, 1. Okay, we just use this 8421 method, okay, to find the code, the BCD code for each of these decimal number. Okay, contoh, nombor 8, what would be the code for number 8? Okay, 1, 0, 0, 0. Number 5, 0, 1, 0, 1. So this is the value that you need, requires to be put to this BCD input. Once you put this number to, insert this number to the BCD input, the 7 segment will display according to this input here. Okay, if you put 1, 0, 0, 0, so your LED will, the 7 segment will display number 8. Okay, let's say like you put 0, 1, 0, 1. Okay, you put a 0, 1, 0, 1 here at this input here. 0, 1, 0, 1. So now the 7 segment, okay, this 7 segment will display number 5. Okay, so by using the BCD 277 decoder, okay, you are no longer need to find out what would be this code here to to display a certain character on your 77. Okay, just give it the code, the PCD code, then after that it will translate. Okay, it will translate the code, okay, the BCD code that you given to the decoder, and it will light up the LED on the 7 segment, okay, accordingly. Okay. Okay, examples here. Let's look at this example. Okay, you are going to write a C code to display 1, 2, 3, 4 at port A. All right, so now we can see here, okay, we have a total of 4 7 segments, and all of these 4 7 segments are connected to BCD code driver, okay, the decoder. Okay, so this is a decoder 1, this is a decoder 2, 3, and 4. Okay, so you're going to display, okay, so this is your target lah. Okay, you're going to display 1 here, 2 at the decoder 3, 3, and number 4. Okay, so how to do it? Okay, and here you can see here from this 7 segment, from this decoder, okay, it only requires 4 pins that need to connect it to your GPIO pin. So here we can assume this is a PA0 lah. Okay, so this is a PA0 until PA3, followed by PA4 until PA7. So this one here, PA8 to PA11, and this is a PA12 to PA15. Okay, if you're not using this 7 segment here, what we call here the decoder here, what happened here is, all right, to connect 7 segment, you require how many codes, how many ports here? You are required to connect to 2 ports. Okay, so 1 port. Okay, the first port here, PA, contoh lah, I give you PA0. Okay, we'll connect it to the first LED until PA7, and then next is a PA8 to PA15. So 1 port, okay, can only connect it to 2 7 segments. Okay, if you're not using the decoder, okay, the 7 segment decoder. Okay, so in order to connect to 4 7 segments, you are required to have a total of 2 ports. Okay, so this is a PB0 until PB7, and this is a PB8 until PB9. PB15. But if you use the 7 segment, the decoder, okay, it's not only, okay, reduce the number of GPIO pin needed, it also, okay, makes easier for you, okay, which is you no longer need to find out the 7 segment codes, okay, in order to display a proper digits lah to your 7 segment. Okay, so this is the advantage lah, okay, by using the 7 segment decoder to your 7 segment display, along with your 7 segment display. Alright, so we go back to our examples here. Okay, you're going to write a C code, okay, to display number 1, 2, 3, 4 at port A. Okay, so what you need to do? I need to copy back this thing here. Okay, so you just write the same things lah. Okay. Okay, you include the file. Okay, the STM32 file, and then start with your main program. Under the main program, okay, start with the initialize the GPIO clock. Okay, since here we only use a port A, so the number that you need to give here is now become 0x01. Okay, next is a model. Okay, the model register. Okay, since you can see here, all of the port A pins are need to be connected to 7 segments. So from PA0 until PA15, okay, you need to make it as a output port. Okay, so now we change it here. No longer use a GPIOC. Now it becomes GPIOA lah. Okay, and the model value will be 555555. Okay, all of the GPIO pin A, okay, are initialized as a output port. Okay, then after that, okay, make your output, okay, set number 3. Okay, make the output to operate under the push pull. All right, so at the GPIOA O typer, okay, you can just give with 0. So now, okay, this output here are what we call it, are operate under the push pull mode. Okay, next. We started with the programs lah. Okay, while one, okay, GPIO A, yani you change it to A, ODR. So what value that you need to give here in order to display 1, 2, 3, and 4? Okay, can someone tell me? Okay, anyone can help me? What will be the value that I need to give to the GPIO A ODR in order to display 1, 2, 3, and 4? Anyone? Aiman, okay, can you tell me what value that you need to give to the GPIO A ODR in order to display 1, 2, 3, and 4 on this 4 unit of the 7 segment? Okay, don't forget we use the what we call the decoder here, 7 segment decoder. What will be the value? Okay, to display number 1, what will be the value that you need to give here? 0, 0, 0, 1 lah. To display number 1 is a 0, 0, 0, 1. Number 2, 0, 0, 1, 0. What about number 3? 0, 0, 1, 1. And number 4 is a 0, 1, 0, 0. Okay, and based on this number here, okay, you just change it to hexadecimal, so you will get 1, 2, 3, 4. Okay, the same number that you need to going to display here. So you just give 0x1, 2, 3, 4 and send it to your GPIO A ODR. Then after that, the 7 segment will display 1, 2, 3, 4 to this 7 segment. Okay, so that is the best thing lah. Okay, using this decoder down here. Okay, so you no longer need to find out what would be the value, okay, the codes in order to display a certain digit on the 7 segment. Okay, you just give to display number 1, you just give 1. To display number 2, just give 2 to your 7 segment. To display number 3, just give 3 to your 7 segment. Okay, just like that. Okay. And then moving on to another, moving on to this slide. Okay, so this is another 7 segment lah. And this 7 segment, we call it as a multiplex 7 segment display. Okay, what is the multiplex 7 segment display? A multiplex 7 segment display share common connection among multiple digits, okay, to reduce, okay, this is the target lah, to reduce the number of GPIO pins required. Okay, so the digits are activated one at a time in quick succession, leveraging the persistence of the vision of to create the illusion that all digits are lit simultaneously. Okay, so you can see here in this multiplex 7-segment display. Okay, for this example, we have a total of 3 7-segments, which is all of these 3 7-segments are share the same LED connection. Okay, you can see here we have the LED A, okay, connection for pin B, connection for LED C, D, E, F, G, and H. Okay, the DP. Okay, the DP you sambung jugalah ke bawah tu. Okay, the decimal point. If you're not using the DP, okay, just give it with a 0. Okay, if communicated lah. Okay, next. Then, from here, okay, there are 3 controller or 3 enable. Okay, you can see this is for, this is the first enable lah. Okay, this one is for the first enable 1. This is the enable number 2, and this is enable number 3. Okay, so this enable here will enable the 7-segment. Okay, because we have a 3 7-segment inside of this multiplex here, 7-segment. Okay, one enable will control 1 7-segment. Okay, for example, if you're going to display a value, okay, at this 7-segment, let's say I give, okay, this one here. I'm going to display number at this 7-segment. Okay, so I need to enable, okay, I need to enable this 7-segment so that it will display the value on only for this 7-segment. The rest of the 7-segment, the other 2 of the 7-segment will not display anything lah. Okay, let's say if we're going to display number to this 7-segment, so I need to enable, okay, the third 7-segment here. Okay, what value that you need to give here, enable, most of the time the value we need to give, okay, based on, we need to look based on the multiplexer itself lah. Some of the multiplexer have a, what we call here, enable high, okay, which is you need to give a logic 1 to enable it, or some of the multiplexer we need to have a enable low, okay, in order to enable it. So assume that in this multiplex 7-segment is a high enable. So high enable means that you need to give 1 to this enable it pins, then after that the 7-segment will be working, or the 7-segment will be turned on, and it will display whatever value based on the value you give on the this pins here. Okay, pin A until pin H. Okay, so let's say lah, okay, I give you examples. Same thing. Okay, you're going to display 1, 2, 3 to this 7-segment. Okay, how to write a program? Macam mana nak tulis program? Okay, so what you need to do? Okay, first, what we need to do is, okay, we need to find out, okay, the code, the 7-segment codes, because we doesn't have any decoder here. Okay, if you use decoder, then after that, no need to find out the codes lah, the 7-segment code. But here, there is no decoder, the 7-segment decoder, the binary code decoder. So what we need to do, we need to find out what would be the code, okay, in order to display 1, 2, and 3 to that 7-segment. Okay, so we go back to this table here. Okay, to display number 1, number 1. Okay, so this number 1, the code will be okay, 0x06. Okay, to display number 2 is 05P, and to display number 3 is 0x4F. Okay, so this will be the code, okay, that you need to give in order to display 1, 2, 3 on the on that multiplex 7 segment display. Okay. Okay, now let's see lah. Okay. Pin A here. Okay, the pin A from the multiplex 7 segment is connected to PA0. And then pin HDP here is connected to PA7. And then enable pin, okay, enable pin, let's say this is an enable 3. So this is a enable 1, enable 2, and enable 3. Okay, enable 1 is for the first 7 segment lah. Enable 2 for the second 7 segment. And enable 3 is for the third 7 segment. Okay, enable 1 is connected to PB0. This is a PB1 and this is a PB2. Okay, so how to write a program? Okay, can you help me how to write the program? Okay, I just put it here. Okay, so what you need to do? Okay, first, macam biasalah, okay, as usual, okay, include the file, and then started with your main program. Okay, and under the main program, the very first step here is, okay, you need to enable the clock, GPIO clock. Okay, what would be the GPIO clock's value here? Okay, anyone can help me? What would be the value for the GPIO clock? Okay, you need to use the port A and port B. Okay, you have a port A and port B. Okay, what value that you need to give to enable port A and port B?
Zero, 3.
Okay, 3. So we need to have 1, 1. Okay, so this is A, B, C, and D. A, H, B, Y, and R. So the value will be 0x0, 3. So now you already enable GPIO-A and GPIO-B clock. Okay, then after that, okay, we start, okay, initialize, okay, setting the mode register. Okay, so this is step number 2 lah. Okay, for the port A, what you need to do for the port A? Okay, port A connect to the 7 segment. Okay, from PA0 until PA7. So connect to 7 segment. This port A you need to initialize as an input port or output port. Okay, anyone? You need to set GPIO-A to act as an input or output. Okay, Fahim, input or output for GPIO-A?
Input.
GPIO-A, you can see here GPIO-A, PA0 until PA7. Okay, you connect them to the 7 segment. So it must be output lah, because 7 segment is a display. Display is a output. Okay, so you need to make it as a output port. Okay, to make it as an output port, we go back to the model register. Where is the model register? Oh, typer. It set with this set. Okay, this is a model register. Okay, so the mode register, Okay, since we need to have a PA0 until PA7. Okay, so PA0 until PA7, you need to look at the model 0, model 1, model 2, 3, 4, 5, 6, and 7 only. Okay, all these models here, okay, you need to give a proper value lah in order to make it as a output port. Okay, to make an output port, what value that you need to give? You need to give a 0, 1. Okay, so you give 0, 1 to this bit, 0, 1 to this bit, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, and 0, 1. So PA0 until PA7, you make it as an output port. And what will be the value here that you need to send to the mode register? 5, 5, 5, 5. Okay, so we go back here.
I think it's only until PA6.
Hmm?
PA0 until PA6 should be 7 pin.
PA7 because I connected the decimal point as well.
Okay.
Because this one here doesn't have the decimal point, you see? Only up to G. So I put another one. You see here, this we have a DP here. The DPP is not connected to the pin. So I just connect the DP to the pin, which is a PA7 lah, to make it as a 8 pin. So we have a total of 8 pins lah.
All right, understood.
All right. So value is a 0x5, 5, 5, 5. So PA0 until PA7, you make it as a output. Okay, so ini this one enable clock for GPIOA and GPIOB. Okay, next we have another port here, port B, okay, which is PB0, PB1, PB2. And this PB0, PB1, and PB2 is connected to the enable input of the 7 segment. Okay, you connect to enable input of the 7 segments. So the question here is, okay, PB0 until PB2. Okay, you need to make it as an input port or output port. Okay, enable inputs. Connect to enable inputs of the 7 segments. So this will be the controller lah. Okay, to control which 7 segment will light up. Is it the first 7 segment, second 7 segment, or a third 7 segment? So what would be this pin here? You need to initialize it as an input or output. Anyone can help me? Yeah, output. Okay, so we need to make it as a output. Why? Because we control how the 7 segment will behave. Either it's a turn on or turn off. If we give 1, it will turn on. If we give 0, the 7 segment will disable. Right? So it is our output as well. Okay, so GPIOB model. Okay, and what value here? 0x00. So you need to go back lah to the model. Since we only have 3 pins here, go back to the model. Okay, 3 pins. Okay, this one not required. This one also not used. This not used. Okay, only model 0 until model 2 is needed. Okay. Okay, model 0, model 1, and model 2 is needed. So the value will be 5, and this one is 1, 0, 0. Okay, so this will be the value that you need to send to port P. Okay, to make the PB0 until PB3 as a output port. One. Okay, so PB0 to PB2 output. Okay, next. What we need to do? Step number 3. Okay, determine, okay, select the output types. Either you're going to be it's a push-pull or open drain. Okay, so we just use the push-pull because we don't want to enable the pull-up resistor. Okay, just use the push-pull. So just simply write GPIOA O type equal to 0 and GPIOB O type equal to 0 as well. Okay, then after that, okay, we started with the main programs. With the programs lah. Okay, to display 1, 2, 3 to this 7 segment. Okay, so here this is the active high. We use the active high. Okay, based on this enable input, this is an active high. Okay, means that this is a 7 segment. We have 3 7 segments. Okay, each of the 7 segment will have enable input. This is an enable input. Okay, so this is an enable 1, enable 2, enable 3. So this is a 7 segment number 1, 2, and 3. Okay, now we're going to display number 1 at 7 segment 3, number 2 at the second 7 segment, and number 3 at the first 7 segment. So how are we going to display this number here? Okay, you cannot directly give the value, simply give the value as this example. Why? Because these examples here, you can see here, the pin for each of the 7 segments are not paired. Okay, they have their own pins. Okay, compared to this here, okay, they are sharing the same pin for the LEDs. Okay, to light up the LEDs. So now, okay, since it shared all of the LEDs are shared the same pins, so the enable input, okay, will have a crucial play lah. Okay, in order to make sure that a proper value will be displayed at the certain 7 segment. Okay, so enable is very important. Okay, so here let's say lah. Okay, so now we are going to display number 3. Okay, this is the very first value that we're going to display. Okay, if you just write down something like this, okay, we just write let's say, okay, first GPIO. Okay, GPIOB. Okay, we need to have the GPIOB ODR. Okay, equal to, let's say I give a 0B lah. Okay, 0B is a binary, easy for you to follow. Okay, I give 111. What happened? 0B 111 means that this is the value that I give. Okay, because this is a PB0, this is PB1, PB2, and this is a PB3. Okay, if I give a 0111, what happened? Okay, all of these 3 7 segments is enabled. Okay, means that it's working lah. Okay, and I give the GPIO what value? A ODR with 0x 4f. Okay, this is to display number 3. Display 3. So what happens? If I at the controller, okay, at the enable input, I give 0B01111. So means that this 3 will like turn on, will be enabled. All the 3 7 will enable. Then the second, the next step, okay, I give another value 4F to GPIOA ODR. Okay, GPIOA ODR, you can see here. It is connected to the LED of the 7 segment. So what happened? Now all of these 3 LEDs, 3 7 segment will display number 3. Okay, 3333, because I enable all of the 7 segment, okay, to display the same number at the same time. So we don't want this. Okay, we don't want all of the 7 segment display number 3. Okay, we want, okay, our target here is 7 segment 3, number 3 need to display number 1, then followed by 772 is number 2, and 773 is number, and 771 is number 3. This is our target. Okay. So what we need to do is, okay, we need to disable lah. Okay, we need to disable E2 and E3. We need to disable it. Okay, only E1 will display number 3. So what happens? When you disable, okay, only first 7 will display number 3, while 772 and 773 will turn off because you disable it. Okay, so this is the correct value lah that you need to give to your enable input. Okay, 00001. Or you can write 0x01. Okay, next. To display number 2 on the 7 segment, do we need to call a delay? Okay, no need to call a delay. What happens if you call a delay? When you call a delay, okay, you cannot, when you write the program, okay, so this will display, let's say lah, you call a delay 1 second. So this will light up 1 second. The next sequence, only the second 7 segment will light up for 1 second. Okay. Meanwhile, the first 7 segment and third 7 segment will turn on. Okay, we don't want that. Okay, we want all of the 7 segment display, okay, lights up at the same time. So no need to put a delay in between first 7 segment and second 7 segment. Okay. So here I'm going to copy the okay. So the second one here, I just change. Okay, now become 010. Okay, so when 010 means that you give 010, only second 7 segment will be enabled. Okay, now I'm going to display number 2. Okay, number 2 change 4F to 5B. Okay, so now this one will display number 2. Okay, while third 7 segment and first 7 segment turn off. Okay, and the last one here is GPIOB ODR. You give the value 0B0100, and then the value here is to display number 1. Number 1 we already identified 0. Okay, so here what happened? Okay, when I give 100, okay, only this 7 will display a value, while 771 and 772 will disable. Okay, so next, okay, we just close the curly brackets, and this when you write execute this program, then you will see 1, 2, 3 will be displayed on this multiplex 7. Okay, so no need to put a delay in between here. Okay, in between no need to put a delay. If you put a delay in between here, what happens? Okay, this LED, this 7, okay, you will see lah. The first number is number 3. Then after that, okay, it will turn off. The second number will be number 2. Will display on the second segment. Okay, then it will turn off. After that, number 1 will display on the third segment. Then it will turn off. Okay. Any question up until here before we go to the input interfacing? Okay, we already finished the output interfacing. Now we're going to look at the input interfacing. Ada soalan tak from you guys? Okay, if no question, then we move on to the input interfacing. So in ARM, pull up and pull down resistor are used, okay, to ensure that input pin has a defined logic state, high or low, when no external signal is applied. Okay, because our push button, every time you using an input, okay, so it will produce either a logic 1 or logic 0. Okay, let's say like you use a active high push button. For the active high push button, when you push the button, it will give you logic 1. When you not push the button, it will give you logic 0. So how to drive a logic 0? So to drive a logic 0, we need to have this pull up resistor. Okay, so this pull up and pull down resistor is used, okay, to produce a logic high or logic low when no external signal is applied. So STM32 provide internal pull up, pull down resistor that can be configured via software. Means that, okay, by using a program, a line of code, you can enable a pull up and pull down resistor. Okay, so let's look at this. We have 2 switches here. Okay, the first switch, this is a active low switch. Why active low switch? You can see here, when you press this switch, okay, it will give you a logic 0. Okay, when you not press the switch, what happens? Okay, if you by right, okay, you need to have the proper way to connect a switch is you need to have a VCC. Okay, this is I draw the active low switch. This is the proper way to connect a switch. Okay, you need to have a VCC. Okay, and then after that, okay, this will go to the A. Then we have a switch. Okay, and this is your micro P, STM32. Okay, so this is actually the proper way to connect active low switch. Okay, we see to have the VCC, and then you have a ground. For active low switch, okay, the ground need to connect it with your push button. Okay, so when you push this button here, it will produce a logic 0. Okay, and go to your STM32. Okay, if the push button is not pressed, what happens? Logic 1 from VCC will go to the STM32. Okay, so this is the proper way to connect a switch. Okay, sometimes, okay, you forgot to put a VCC here. Okay, so when you forgot to connect the VCC, okay, so suppose you need to put the VCC here, okay, but you forgot to connect the VCC. So what happens? Okay, you need to enable the pull-up resistor inside of the microcontroller. Okay, there is an internal pull-up and pull-down resistor inside of a microcontroller, which is you can enable it by using a codes. Okay, right, by using the pull-up, pull-down resistor. Then after that, the pull-up and pull-down resistor internally. Okay, you can enable the pull-up and pull-down resistor internally inside of the microcontroller. Okay, similar to this active high switch. Okay, by right, a correct way to make an active high switch. Okay, you need to have something like this. VCC. Okay, connect to this ground. This is the okay. So this is the STM32. Okay, so this is a correct circuit for the active high switch. And when you forget to put the ground here, okay, you forget to put a ground, okay, you can enable the pull-up, internal pull-up, internal pull-down resistor to produce a logic 0. Okay, by using a software lah, by using a program. Okay, just write the codes. Okay, so what is a pull-up resistor? What is a pull-down resistor? So pull-up resistor used when the input pin should default to high when not driven internally. Okay, looking at this, okay, at this circuit here, when you not press this switch, okay, what happens? It need to produce a logic 1. So how to produce a logic 1? By using a pull-up resistor, which is a VCC from, okay, the VCC, the high value from VCC will go to your GPIO pin, okay, to produce a high logic. When you press this button here, then after that, a logic 0 will go to your STM32. Okay. Next, what about the pull-down resistor? Okay, the pull-down resistor used when the input pin should default to the low when not driven externally. Okay, means that you can see here, when you don't push a buttons, okay, so you need to produce a logic 0. Okay, how to produce a logic 0? By enable a pull-down resistor. Okay, a pull-down resistor means that 0 from the pull-down resistor will go to your GPIO pins. And when you push the button, then after that, logic, okay, will come in from this VCC. Okay, so this is the definitions of the pull-up and pull-down resistor. Okay, so how to enable the pull-up and pull-down resistor internally? Okay, to enable the pull-up and pull-down resistor, we need to use the GPIO PDR register. Okay, PUPDR, not PUDPR, PUPDR. Okay, so GPIO PUPDR used to configure a pull-up and pull-down resistor from the GPIO pin of the specific port. And this register ensures a defined logic level, either a logic high or low on the pin when no external signal is connected. When you not push a button, then okay, that signal will be produced by the either a pull-up or pull-down resistor. Okay, and this PUPDR is used to prevent GPIO input pin from floating when no external input is connected. Okay, so this is the registers lah. Okay, we have a total of 32 register, 32-bit register, and from this 32-bit register, okay, we can into 6 PUPDR. Okay, you can see here the first one. Okay, the first PUPDR, this is a PUPDR 0. So this is for pin 0 lah. Okay, PA0. PUPDR1 is for PA1, and then PUPDR7 is for PA7, followed by PUPDR8 is for PA8, and last one is for PA15. Okay, it's quite similar to what we call here a mode register. Okay, one PUPDR, okay, will have 2 bits. Okay, and the combination of bit will something like this lah. If 0, 0 means that no pull up resistor, no pull down resistor, means that you disable pull up and pull down resistor. And you give 0, 1, means you're going to enable the pull up resistor. Okay, and this one pull up resistor when you use the active low switch. Okay, active low switch. Okay, in order to give to produce a logic 1, you need to enable a pull up resistor. Then 1, 0, this to enable a pull down register. Okay, when you're going to use this configuration, when you switch is a active high switch. Okay, when the switch is not pressed, okay, to make a logic 0, you need to use a pull down resistor to produce a logic 0. And last but not least is 1, 1 is for a reader. Okay, we only focus on this value here. 1, 0 and 0, 1. Okay, next we move on to the switch. Okay, we already looked at the pull up and pull down resistor, and now we're going to look at the switch. Okay, because pull up and pull down resistor can needed to be enabled when, okay, your switch doesn't have a pull up and pull down resistor externally. Okay, so a switch is a simple input device used in embedded system to toggle, okay, between two states, either is a on or off. Okay, on means that the switch is closed lah, the circuit is closed. Okay, off means the circuit is open. Okay, there are two types of switch. Okay, we have an active low switch and active high switch. Okay, so active low switch trigger an action or input when the signal is low. Okay, you can see here, this is your switch. Okay, when you close the circuit, okay, it will produce what logic? Logic 0 will go here. Okay, when you close the circuit, logic 0 will go there. When the circuit is open, logic 1, okay, from VCC will go to your MCU. This is an active low switch. Okay, and then for the active high switch, trigger an action or input when the signal is high. Okay, you can see here. Okay, this is a switch. Okay, when the switch is closed, okay, logic 1 from VCC will go to your MCU, will go to STM32. When this switch is open, what happens? Ground, logic 0 from ground will go to the MCU. Okay, then when you have this pull up and pull down resistor externally connected to your switch, okay, you no need to enable the pull up and pull down resistor internally. Okay, so no need to configure this lah. Okay, tak perlu. Okay, when your connection of switch is correct, have a pull up and pull down resistor accordingly, then no need to enable the pull up and pull down resistor internally in your program using the PUPDR register. If you forgot to connect, okay, pull up resistor to your active low switch, or pull down resistor to active high switch in externally, then after that you need to enable the pull up or pull down resistor inside of your microcontroller. Okay, examples. So an active low push button is connected to PC13. Okay, whenever the push button is pressed, LED at PA5 will turn on and off when released. Okay, we just draw the circuits here. We have an active low switch. Okay, so this is active low switch connected to PC13. Okay, and then we have the PA5 connected to LED. Right. So you're going to write the programs. Okay. Whenever the push button is pressed, okay, when you press the push button, LED at PA5 will turn on. Okay. Press LED on. Not press LED on. Okay. So now we're going to write the program. So here, same thing. Okay, you need to include this file and then started with your main program. And this is your first step. Okay, you need to enable the GPIO clocks. Okay, in these examples here, we have PA5 and PC13. Okay, so you need to enable port A, pin number 5, and port A and port C clocks. So how to enable the port A GPIO A and GPIO C clock? Okay, you need to give this number lah, 0, 5. Okay, so by giving a 0, 5 to AHB, YNR, then after that, okay, you already enable the GPIO A and GPIO C. Then step number 2. Okay, what will be the step number 2? Okay, step number 2, okay, you need to set, okay, PA5 connected to LED. So PA5 must, you need to make it as an output port, while PC13, which is connected to input, to switch, so you need to make it as a input switch, an input port. So how to do it? So GPIOA model equal to 0x0400. Okay. Next, number 3. Okay, this is where you're going to make your output to operate. Okay, using a push-pull. Okay, so how to do it? Okay, just use the GPIOA O typer equal to 0. Okay, you can simply write down this here to GPIOA O typer sama dengan 0. Okay, then after that it will become an the output will operate, okay, under the push-pull mode. Okay, what about the GPIOC? Okay, GPIOC only, okay, PC13, you need to make it as an input. Okay, you can simply write here as the GPIOC model equal to 0, no problem. Okay, because we don't have any port C connected to output, so just simply write, okay, all of the port C you need make it as a output port. Okay, then after that, okay, we need to enable the pull up resistor. Why I need to enable the pull up resistor? You can see here there is no pull up resistor, okay, in this circuit, okay, on the external circuit of my switch. So I need to enable the pull up resistor. so that it will produce a logic 1 when the push button is not pressed. So how to do it? GPIOC, okay, PUPDR sama dengan, okay, what value that you need to give here? Okay, we need to identify lah. Okay, based on this, okay, our what we call here, switch is connected to PC13. Okay, so PC13 you need to identify lah, where is the PUPDR for PC13. So this is the location of the PUPDR for PC13. Okay, so PC13 is here. What value that I need to give here? I need to give 0, 1 to this value. Why 0, 1? Because to enable a pull-up register. Don't give 1, 0. Why? Because we are using the active low switch. If we enable 1, 0, no point. Okay, because the switch already, when pushed, produce a logic 0. When you enable 1, 0, when not switch, when the switch is not pressed, it will produce a logic 0 as well. Okay, so no point. We need to have either a logic 0 and logic 1. Okay, so we just enable the pull-up register. When the switch is not pressed, it will produce a logic 1. Okay, and based on this information here, okay, the value that you need to give to the PUPDR will be 0, 4, 0, 0, 0, 0, 0, 0. Okay, that will be the value. Okay, GPIOC PUPDR OX 0, 4, 0, 0, 0, 0, 0, 0. Okay, so this one you need to have up to 5 steps lah. If you involve if you have a what we call here input and output, so you have up until step number 4. Okay, which is the 4th step is to enable the PUPDR. PUPDR. Okay, next. Okay, next is a while loop lah. Okay, while. Okay, we're going to check lah whether the switch is pressed or not. Okay, so this one we already did in the previous one. Okay, which is you need to find out what would be the mask value. Okay, so this is the mask value. Okay, the masking value. Okay, you're going to check the IDR, and with the masking value, is it equal to this value? If yes, then what happen? Okay, because if a 0 equal to 0 means that the switch is pressed. So LED need to be turned on. LED on. How to turn on the LED? By sending this value 0020 to PA5. Okay, on the ODR. Okay, else to turn off LED off, just give GPIOA ODR equal to 0. Okay, this is by using the ODR. What happens if you're going to, okay, I don't want to use the ODR. I'm going to use the bit set reset register. Okay, no problem. Okay, just write down replace ODR with GPIOA BSRR. Okay, BSRR, yes. BSRR equal to, okay, 0x0020. Okay, so your LED will turn on, and then GPIOA BSRR, okay, to reset 0x0020 followed by 000. Then the LED will turn off. Okay. Another example. Okay. So previously using a active high. Okay. So active low. Now we are going to use the active high. So an active high push button is connected to PC13. Okay. Whenever the push button is pressed, PA5 will turn on. If not, PA5 will turn off. Okay, so this is a PC13. So active high push button means that this is a VCC. PA5, same thing, LED. Okay, so what you need to do, same things lah. Okay, include the file, and then after that, okay, enable the GPIO clock. Okay, at port A and port C. Okay, step number 2, make the port A as PA5 as an output port, PC13 as input port. Okay, done. Step number 3, okay, for the output port, okay, make it as a push pull output. Okay, to be operated under push pull modes. Okay, just give GPIOA or type equal to 0. And then after that, okay, now since this is a VCC active high, so for the active high, we need to enable the pull down resistor. Okay, active high need to enable a pull down resistor. No more pull up resistor, pull down resistor. Okay, so what will be the value? Go back to this, okay, identify where is a PC13. Okay, the PC13 is here. So what value that you need to give here? Pull down resistor, you need to give 10. So 10. So the value now change from 4 to 8. Okay, so now we change it now because so here GPIOC PUPDR equal to 0x08 00000. Okay, so now you already enable the pull down resistor internally. Why we need to enable the pull down resistor internally? Okay, because in this circuits here, we doesn't have a circuit for pull down resistor. So you need to enable it internally inside of the microcontroller. Okay, and then check lah. Okay, whether the switch is pressed or not. Okay, same things. Okay, identify the masking. Okay, and with the IDR, and then equal to, is it equal to 0 or 1? If it equal to 0, so what happen? Okay, so means that the button is not pressed. Equal to 0, the button is not pressed, so the LED need to turn off lah. Okay, so this one here, okay, please change here, not turn on. This is a turn off. Okay, when equal to 0, the LED need to be turned off. Okay, why? Because the switch is not pressed, so the GPIO AODR value must equal to 0, not this value. This is to turn on. Okay, which is wrong lah. Okay, so next, else. Okay, to turn on the LED. So the value is GPIOA ODR equal to shift 1 to the left. Okay, so you can use this data shifting to turn on the LED. All right. Until here. So this is the switch lah. We always use either a push button switch or a slider switch. It works the same lah. Okay. Next, we look at the DIP switch. Okay, so DIP switch consists multiple small on-off switch in a single package. It means that in one package you have up to 8 switches. So each switch has to position Either you're going to make it on, okay, close the switch, or off, open the switch. Okay, to toggle on, the switch connect it pin to the electrical signal. Okay, to toggle off, it disconnect circuit, leave it open or connected to a default state using the push up or pull down. Okay, so this switch is similar to the slider switch lah. Bila kamu turn on dia, means that the circuit will be closed. Okay, so the value from the switch will go to the microcontroller, depending on whether it's an active high switch or active low switch. If the switch is toggle off, means that the circuit is open. Okay, so the value will come in from the pull up or pull down resistor. Okay, that is for DIP switch. How to write the program? Same. Okay, if you use the active high DIP switch, okay, you need to enable the pull down resistor. If you use an active low DIP switch, you need to enable the pull up resistor. Okay, moving on to generating a delay. Okay, there are three ways to generate a delay in ARM processor. Okay, the first is using a loop. Okay, you can create a loop to generate a certain delay. The second one, we can use a predefined function. Okay, there are a lot of predefined functions that you can use to generate a exact delay. Okay, the advantage and the disadvantage using a loop is that you cannot produce an exact delay. Let's say like you're going to produce a 2-second delay. The delay will not get 2 seconds. Okay, maybe you will get 1.8 seconds or maybe more than 2 seconds if you're using a loop. But if you use a predefined function and hardware timer, okay, you will get the exact delay generation. Okay, so the third is using the hardware timer, which is we using the timer, okay, to create a delay. But for the timer, you need to write a program lah, okay, to that delay. Okay, in this class, we only cover using a loop and using a predefined function. Timer will not cover in this class because it's quite long lah. Okay, you need to learn a few register, okay, before you can write the program. Okay, so this is the first one. Okay, using a loop. Okay, using a loop is a simple way to create a delay by using creating a software loopings. Okay, you just create a loop and then it will create a delay lah. But the delay will not you will not get exact delay that you needed. Okay, so this method is straightforward but not precise. Okay, as it depends on the CPU and compiler optimization. So how to delay? So this is the delay. Okay, using for loops, you can create a delay based on the how many times the counter will execute. Okay, the second one here is using a predefined function all underscore delay. So in STM32, Hall, or the other names is a hardware abstraction layer. The Hall delay is a convenient function used to introduce millisecond level delays. Okay, so it's based on the SysTick timer. Okay, built-in timer in Cortex-M core processor. So how to use the Hall delay? First, you need to enable to initialize the Hall lah. Okay, initialize the Hall and set up the SysTick. Okay, the SysTick is a timer. Okay, inside the STM32, and then you need to enable the system clock configuration. Okay, so this one is default lah. Okay, just use call the system clock config. Then after that, you will configure the STM32 clocks. Okay, so how to use the delay? Hall delay. Okay, just use this function here. Hall underscore delay bracket. Okay, what are the delay that you're going to generate? Okay, if you put 1000, means that is a 1000 millisecond, which is equivalent to 1 second. If you're going to generate a 2 second delay, so you need to put 2000 inside of this bracket. Okay, if you're going to make a 500 millisecond relay, just put a 500. Okay, then it will generate a 500 millisecond delay. Okay, so you need to remember these three things lah. Number one, okay, initialize the hull and set up the SysTick. Number two, okay, configure the system clock. Okay, just use this function here. Okay, just initialize this function. Then after that, use the hull delay to generate the delay. Okay, so that is for today. Okay, we already finished module 8. Any question up until here? Do you have any question, guys?
Sorry, doctor, is it possible to